Hi there, folks. Today we're looking at assessing normality, all right? So we've looked at normal distribution and we've investigated some of the special characteristics that it has, but now we want to kind of go the other way. We're going to start with a set of data and determine if that set of data is normally distributed. So instead of being given normally distributed data and being asked questions about the data set, I want to know if a data set is normally distributed, okay? And so all we're going to do is we're going to check to see if it has the special characteristics of normal distribution. Remember, normal distribution has to have a single peak, it has to be symmetrical, it has to follow that nice bell shape, and it should follow the empirical rule, which is that 68, 95, 99.7. So all we're going to do is we're going to look at the data from a couple different perspectives. We're going to look at the shape of it from the perspective of the graph. We're going to look at the mean and the median to talk about predicting the shape and that kind of stuff. And we're going to see if it looks the way normal distribution is supposed to look. And then we're going to see if it fits the empirical rule the way normal distribution is supposed to, okay? And when we talk about this, if we look at the empirical rule and, our data has, 70% of the data instead of 68% of the data within one standard deviation, and it has 96% of the data within two standard deviations instead of 95, that is pretty close, all right? So we want to know, is it about following the empirical rule? Does it approximately follow the empirical rule, okay? So we kind of have to give it a little bit of leniency as we look at these things. For example, when I look at this one, I want to determine if the data is normally distributed. And so I have a fairly small data set here. It looks like the heights of girls in a class. And I want to know if this data is normally distributed. And so the first thing I might want to do is I might want to check the shape of this thing a little bit. And I could find the mean and I can find the median and that kind of stuff, which would help me predict the shape. If I took this off to the side and found the mean, added these all up and divided by how many we had here, or plug this into a graphing calculator that'll calculate the mean for me, or put it into a spreadsheet and let it calculate the mean. Those are all things that we should have done before. I'm not going to walk you through that here, but we get a mean of 63.38, okay? And so right away we're looking at this thing thinking, okay, it's probably, we also have to identify the median. The median on this one, if we find the middle, is 64. And that's pretty easy. We just count to the middle of the thing. So now when we look at these two things together, we would predict that, hey, these are pretty close, so we're going to predict that this is symmetrical, okay? If right away we're looking at this thing going, hey, there's no way this thing is symmetrical, it's definitely skewed to the left or it's definitely skewed to the right, I might not need to look any further. I might not need to investigate any further. I could stop there and say, you know what? This is not normally distributed because normal distribution has to be symmetrical. So since it is symmetrical, let's investigate a little bit further. So maybe we'll graph this thing and look at the shape that way, okay? So if I were to graph this thing, and I could have done this right from the start, I think a dot plot is a really good tool to use here. It's pretty small data, and there's a pretty small range. It only goes from 57 to 67. So I'll do 57, 58. I'm just going to label every other so these aren't running together like that. Oh, I went too far. That's okay. So let's see, 58, 60, 62, 64, 66, 68. There we go. And so let me go ahead and do my dot plot. Looks like I've got a 57 as my smallest one. And then I have a 59. And I'm just going to go ahead and fill in my dot plot. Two of these. Two of these. Again, just filling in my dot plot. Okay, so when I look at this thing, as I look at this, yeah, it's somewhat symmetrical. It's not perfect. There is what appears to be maybe an outlier off to the side over here. So I'm still kind of on the fence of this one. When I look at the shape of the data, it looks like it might be skewed slightly. If we kind of ignore this guy over here, it looks a little bit better. So it's pretty close. I'd say maybe it's skewed slightly left. But, because we're estimating, even if we think it's skewed slightly left, so I'll put a little note here. So just ever so slightly. Even if we think it's skewed a little slightly left, because we're estimating, I think that's close. I think that's close enough to being symmetrical that I should investigate further, okay? So the last thing I'm going to check now, if I think, okay, this is symmetrical enough to maybe be normally distributed, it is a fairly small sample size, let's check to see if it matches the empirical rule, okay? And so to see if it matches the empirical rule, I have to go calculate the standard deviation. Once again, we're going to go do that using a graphing calculator or using a spreadsheet or something of that nature. And if I find the standard deviation on this one, I get a 2.6, okay? And so for this one, I'm just going to see how that measures up. And so if you kind of think about this thing from the perspective of a normal distribution curve, let me draw kind of a mock one down here. If this thing was normally distributed, well, I would have the 63.38 in the middle, and I would count out by standard deviations. So I'd be counting out by that 2.6. So we're looking at 65.98 and 68.58. And the next one would be 71.18. Okay, so we're just adding that 2.6 each time, then going the other way, subtracting that 2.6 each time. I would get a 60.78. A 58.18 and a 55.58. Okay? And so the idea is that if I look at this data, when I look at values from 60.78, so values from right here to values right here, it should be about 68% of the data. So I just go through and count. I count up how many values are between 60.78, which is the 61 on up to the, 65.98, so up to here. So all of these values are in that range. And so I count them up. There's 15 of those. Well, I just simply divide. 15 divided by the 24 that are here shows me that within one standard deviation, I have 62.5% of the data. That was one standard deviation. For two standard deviations, well, I just look. Let's see how many data values I have from here to here. So now we're looking at two standard deviations. Let me erase these guys. And I just see how it fits. I say, okay, from the 58.18, which is this guy right here, would be the 59 would be the cutoff, all the way to the 68.58. Well, that would include all the ones on this end. So basically, it's everything except that one data value. It's 23 out of the 24. If you divide that, you get 95.8% is within two standard deviations. And then lastly, if I look at three standard deviations, and this one's really an easy calculation to do, three standard deviations would be anything from the 55.58 to the 71.18. Well, that's all of them, okay? So all 24 of these. So within three standard deviations, I'm looking at 100% of the data, okay? So I thought this thing was fairly symmetrical. It was pretty close to being symmetrical, maybe a little skewed, but we'll forgive it a little bit. When I look at the data from the perspective of does it fit the empirical rule, instead of 68, 95, 91.7, we're at 62.5, 95.8, which is really close. And then 100 is actually really close to 99.7. So when I look at this, I would say, you know what? This one's fairly close. And because it's such a small data size, I'm going to say that yes, this one appears to be normally distributed. Notice, I don't say, yes, this is absolutely 100% normally distributed. I say, no, it appears to be, okay? So I'm going to make that judgment call. So I'm going to say, yes, appears to be normally distributed. Okay? And again, we have to give this thing a little bit of lenience. My prediction here is that, yeah, if we collected a bunch more data and got heights from other classes for these female students and looked at all of their heights, and I think that this data would get closer to being normally distributed. I think those percentages would get closer to the 68%. I think the 95 and the 99.7. And I think that symmetry would start to come together a little bit more nicely. And so that's what we're after here, okay? Is this thing fairly symmetrical? Does it meet the empirical rule, or is it close enough to the empirical rule that I suspect this thing to be normally distributed, okay? If I look at this one, again, we're going to do the same thing. We're going to talk about the shape of this thing. I want to know, is this thing normally distributed? So I'm going to look at the shape to see if it's symmetrical and see if it's got one peak in the center. I'm going to look at the empirical rule and see if it matches that close enough, all right, and then go from there. So the first thing I'm going to do before I graph this thing or draw a graph is I'm going to go ahead and find the mean and the median right away. So I'm going to find the mean and the median just because I know I can make predictions about these things just with the mean and the median. And if it's glaring at me that this thing is definitely skewed in some way, then maybe I don't need to pull ahead with the graph. So if I calculate the mean here, I get a 152.4. The median, I get a 151. And so those are pretty close. When I'm looking at this thing, I'd say, yeah, maybe it's fairly symmetrical. Okay, so now maybe I want to go to a graph. Okay, and so I start to graph this thing, and I look at the data, and I say, okay, it goes from 90 to 230. That's quite the spread. So I probably don't want to do a dot plot on this one. Maybe a stem plot would be okay. We could use 9, 10, 11, 12 as our kind of stem. So that might work out because this is fairly small data. The range is a little bit big for that, but we could probably get away with it. Oh, I should have condensed these a little bit more. Let me try again. I think that's all the ones I need, all the way up to through 23. And so the 9, I've got 2 90s and the 98. I've got a 100 and a 104, 5, 2 108s, a 109. Let's see, next I've got the 115, the 118, and then a 122, 128. Again, I'm just filling in my stem plot. Oh, and right away, as I'm filling this thing out, this thing is not looking very good for normal distribution. Okay, because right away I see it looks like my data is not forming a single peak. So even though I predicted symmetry, it might be symmetry but bimodal at kind of the same time. Oh, another gap. Whew. Okay, so when we look at this thing right away, okay, I am not thinking that this is normal distribution. okay? Because of those gaps, this thing has multiple peaks, and even if it had some values filled in between here, it looks far more skewed than I originally thought it was. And so because these values are so spread out, because of the multiple peaks, I was kind of fooled into thinking it was symmetrical based on the mean and the median, when really, as I'm looking at the shape from my stem plot, it doesn't look as symmetrical as I thought it would be. Okay, and so right away, I don't even need to check the empirical rule here. I mean, I could go through and calculate the standard deviation and see if it's close to the 68, the 95, and the 99.7, but there's really no purpose, because even if it matches the empirical rule, I think I'm going to throw this thing out as being normally distributed just based on the shape of this thing, just based on the fact that there's not a single peak in the center the way normal distribution is supposed to be, okay? And so I can go ahead and stop there. I don't need to check the empirical rule. I'm going to say no, the data does not appear to be normally distributed. Okay? So again, we're checking to see if it meets that special criteria. Is it symmetrical? Does it have that single peak? And does it approximately match the empirical rule? And if so, I suspect that the data is normally distributed. Okay?